Good afternoon, everyone. David Pollington, I'm a chartered engineer. I've worked in the telco industry for about 27 years. Vodafone R&D, GSM, I work with operators worldwide. And then a couple of years ago, I swapped over into the investment space, and I work for Block Ventures. They're a deep tech VC based in London. And one of the areas that we really focus on is telco, semiconductor, cloud, compute. So that's kind of why I'm here. Today, I'm going to try and sort of wear my investment hat rather than my engineer hat and sort of take you through from a kind of an investment sort of lens in terms of how they sort of look at AI and how they look at the telco and sort of connectivity industry. So we've already touched on this a lot, with some of the other presenters. AI has really risen rapidly, even though AI is about 70 years old over the past few years. With the advent of the transformer model back in 2017, things have really kind of exploded. And now a lot of people are talking about AI as being the next kind of platform on which a lot of technical innovation is really going to be based. Certainly in the UK, there's a lot of interest in AI as a technology alongside quantum and some of these other things. And then some of the, the luminaries within the field, so people like Sundar, say that they see AI as being as transformative as fire, electricity, and the internet. Even Bill Gates is saying it's the most important thing since the GUI. So, there is a lot of kind of hype and rhetoric certainly over the past 12 months around AI. From the investor's perspective, interestingly, AI is the only sector in deep tech that has actually increased over the past 12 months. With the current global climate, things have really been repressed. Most other deep tech areas have gone down. AI is the only one to have gone up. And, to a large extent, that's because of generative AI. It's been very frothy in the market because of it. But is Gen AI just another bubble? I mean, if you go back, if you remember a couple of years ago, everyone was talking about autonomous vehicles, huge amounts of investment, $40 billion went into trying to crack the problem of autonomous vehicles. But then that's all kind of crashed and consolidated down. Is the same going to happen with Gen AI? There's $11 billion have gone into that over the past 12 months. So it's huge sums of money, but where's it going to lead? Certainly, we're already starting to see commercialization. So, a lot of people talk about, where's the real commercial value in a lot of this stuff. You look at OpenAI, everyone's familiar with OpenAI. Reputedly, they've already made, or they're on target to make $1.6 billion of annualized revenue just from what they're doing with ChatGPT and the other GPT models. And there are people within the company who believe they're going to hit 5 billion by the end of this year. And this is despite the fact that they're actually dropping prices. If you look at the price of GPT-3 that came out about 3.5 years ago, that's gone down by 40-fold to actually make it more accessible. GPT 3.5 has gone down tenfold in the past 6 months, and actually the other day, OpenAI have just dropped the price yet again. But even though they're dropping prices, they're making a lot of money, and because they're making a lot of money, the valuations are sky high. So reputedly, according to Bloomberg, they're already going out to trying to raise more money at a valuation of $100 billion. That's kind of 62 times their forward revenues, which is just massive compared to other software companies in the space. It's just, ludicrous amount of money. But, it's equivalent to Anthropic. Anthropic is about 75 times their forward earnings. So AI in general, if we just zoom back and look at it more sort of generically, a lot of talk about it impacting the economy and the jobs. Some people see by 2030 that the AI industry itself will be worth about $2 trillion, but it's the economic impact of AI that's just really going to hit the most. So some figures here of $15 trillion by 2030. A large part of that will be Gen AI, according to Accenture. And, the IMF have been one of many organizations talking about the impact on jobs. 40% of jobs could be impacted within that time frame, even more so in advanced economies. So let's talk through some of these services that are actually going to be driven by AI as we go forward. So obviously knowledge workers, that links back to what we were talking about in terms of the impact on jobs. So the fact now that with Gen AI, we can generate text, pictures, code, that's going to impact on marketing jobs, on software development jobs. My son is doing computer science at the moment, and I'm thinking, you know what, mate, you might not be able to have a job when you come out, when you graduate, because it'll all be overtaken by AI. So I'm trying to get him interested in AI, but he's just not taken it so far. So, the past 12 months has been all about these massive models, getting bigger and bigger and bigger. This year is going to be all about native multimodality. So we've been having sort of text, based prompts, image-based sort of generation. Now it's going to be bringing everything together with audio, with video, so that you'll be able to have these much more kind of natural interactions with AI as you go forward. And, Google's Gemini Ultra is probably one of the first out the blocks. It's truly fully multimodal. That then sort of brings us into sort of immersive reality, sort of the ambient sort of spatial computing realm. Now, obviously, the AR VR headset market has, been hyped up a few years back. Well, actually, it's been through a number of hype cycles. It's been in decline over the past few years. But now with the launch of Meta's Quest 3 and obviously Apple's Vision Pro, all the analysts are getting excited about this now being the year of the AR VR headset. And interestingly, I've seen some stats on early pre-orders for the Apple Vision Pro. It's already up at about 200,000 orders, and some think it might actually sell 1 million units in its first year, which is way above where people thought it was actually going to get. It may then plateau, who knows, but we'll have to wait and see. But obviously, there are lots of use cases. You guys are probably already fairly familiar with these, about using AR, VR in things like product and service development, process improvements. As Sony and Siemens announced at CES that they're joining to use this for sort of industrial training type applications. Things like medical, being able to actually use these AR, VR glasses to be able to actually practice things like surgical operations, and obviously retail and consumer. So I think we can all agree that the metaverse was overhyped. But there is still a lot of interest in the whole kind of immersive reality, ambient spatial computing space, and how that's going to evolve over the next 5 years. And obviously, Meta is still putting in billions and billions of dollars to try and make it happen. So it will have an impact at some point on the economy. And AI will play a pivotal role in actually generating these virtual worlds and creating these kind of personalized experiences. Then if you flip from sort of human sort of centric experiences to machines, obviously we talked about, I think, digital twins in one of the panels earlier on. So, digital representations of machines, and then using AI to help you to basically optimize the usage of those machines, things like preventative maintenance. That's all going to be coming through a lot more. Interestingly, people are already starting to use Gen AI for actually coding those digital twins. So rather than doing it through kind of a rules-based symbolic type approach, you can actually just get Gen AI to watch it and work out through there how to actually create the model. Robotics and also autonomous systems obviously is another area where we've seen a lot of application of AI in the hyper-connected consumers. So we see AI in things like smart glasses and wearables, etc. That's all right. It's been rushed on, and I thought, I've got longer than this. I'm also the last person, so I can go as long as I like. Anyway, so a lot of people are looking at using Gen AI for actually the re-emergence of personal assistants. I mean, I've been in the industry long enough that we were talking about personal assistants years ago in terms of being a killer application for telco. But now, you see things like Auto GPT and Baby AGI. It's all about using these large language models, but then hooking in external resources and the internet to be able to send these agents off to actually go and do your bidding for you. And probably some of you are familiar with the Rabbit R1 device that came out in CES earlier this year. It's an interesting device because it's a large action model. So basically, they train this thing on watching humans do things like ordering cars using Uber, or listening to the music on Spotify, or e-commerce. And the idea is that you have this device that you can just interact with, and it'll act as a personal agent and go off and do all these things for you based on your bidding. So with all these services that AI is enabling, we're gradually seeing a transition, if you like, of the data that's being generated to fuel these services towards the edge. And I'm going to use the edge as a term quite loosely here. It could be the edge of the network. It could be the far edge where the user devices are. But, as I think as we've already touched on, the effectiveness of AI is very much dependent on access to the data in a timely fashion so that you can actually do something useful with it. So interestingly, when we start moving the data towards the edge, we get a lot of the benefits of the cloud, but also we get the improved responsiveness, which is very important for mission critical services like autonomous vehicles, factories, etc. We get the data autonomy, and that you can keep the data locally. That's very important in some sovereign nations. You reduce your data transfer costs, and it also allows you to do this kind of continuous learning at the edge using the data real time. So, you know, a lot of people would like to move the AI all the way to the very far edge into the actual end devices themselves. And certainly Qualcomm are very keen on this idea. You know, they've come out and said that they really do see a future where you have these personal assistants within your smartphones. Obviously, Qualcomm would say that. They want to sell you the Snapdragon chipsets. But actually, there's quite a lot of problems in actually taking these large language models as we have them today and shoehorning them into these small devices. So there are some different kind of technical approaches that can be used. When you look at a lot of these neural nets, there's a degree of sparsity in the network. So there are parameters and activation weights that are 0 or non-zero when you actually run the computation. So actually, you can shrink down the size of the net and compress it. You can also accelerate it, and a lot of the flagship handsets, you know, the iPhone, the Galaxy, have now got neural engines built in. The other thing you can do, though, is instead of training these large language models on the entirety of the web, which is what obviously OpenAI have done, trillions of tokens, Microsoft and a few others have found that actually if you give them very targeted textbook data, so high quality data, you can actually get to similar performance levels for some of the AI benchmarks, but with much smaller models. So we're going from, you know, 100, 200 billion parameter models down to about 2 or 3. Then once you've only got 2 or 3, you've then got the ability to squeeze it into the memory footprint of these edge devices. But even then, you might decide, actually, I don't want to be running all the AI on my end device. It's going to get hot. Maybe it's going to be a little bit too big, too expensive. So you're going to see wearables offloading some of this back towards the smartphone, or the smartphone offloading stuff back towards the edge of the network or back into the cloud. So really what you're going to see is actually these pools of computing resource in different parts. And this is where we're going to see these AI workloads essentially being sort of distributed across them. So this kind of brings us back full circle then to when we talk about future networks. So we've kind of said AI is taking over the world. There are all these really rich services that it's going to drive. They're all dependent on data. They're all dependent on connectivity and compute. So how can future networks really sort of address that? So 5G Advanced is obviously, you know, one of the areas that is going to be gradually working towards providing some of the connectivity requirements in terms of latency, etc. But going forward, we're going to need to have networks which are much smarter and AI native. And we need to move on from just talking about telecoms and just talking about connectivity. We've got to be talking about sensing. We've got to be talking about compute. We've got to be talking about storage. So this is really where you sort of see this continuity between the telcos and the hyperscalers and how everything needs to come together for the future, for these future services. So AI itself will play a role in actually making these networks smart. I think this came up in one of the previous panels. It is this circuitous thing. So hardware design, we're already seeing AI being used to actually design a lot of future telco hardware. And, you know, people have postulated that it could be used for designing the whole of the physical layer in 6G. So you've got your hardware. Then in terms of planning, as we move to these kind of heterogeneous networks, so we get in 6G with near terrestrial networks, we have small cells, millimeter wave, etc. It's going to become far too complex for humans to try and actually do a lot of this planning. You're going to have to rely on AI. And it's interesting that DeepMind have been doing some generic work on how you can use generative AI approaches for actually applying them to optimization problems. And they found that actually can work quite well. So you could, in future, have a tool for network planners where you can basically transact with it in human language, and it can then help you to actually optimize your network. Obviously, on the network management side, I think this came up earlier, you know, be OSS, BSS, all different areas of the network in terms of how that's run, and then network security in terms of both cybersecurity and physical security. So energy efficiency is something, I think, again, that came up earlier on. But, you know, GSMA, in one of their surveys of network operators, they found that some of them, 40% of their OPEX, annual OPEX, is actually spent on energy consumption. So obviously, this is a significant impact on their carbon footprint. The mobile industry as a whole, with help from GSMA, you know, in line with these Sustainable Development Goals, want to try and move towards reducing their carbon emissions by 2030. And interestingly, most of the operators seem to think that actually AI-based optimization is the way to do it. So yes, they're going to switch to renewables wherever they can, but they actually see AI as having an equivalent impact to reducing their energy consumption as renewables. So, this is really where you use your AI to look at the network, look at how it's running, look at the traffic patterns, etc., and then shut down or put to sleep some of the base stations to actually reduce the amount of energy you're consuming. And if you look at something like the RAN, 70% of the network energy consumption is actually consumed in the RAN. So with AI, you can actually bring it down by about 25%, which is a lot of money. Turkcell have done a lot of work on this, and I think as Dewey said earlier on, they found that actually if they apply AI across their network, they can actually reduce consumption by 63 gigawatts, which is about the equivalent of GPT-4. So a lot of energy. Still, there are some challenges, and I think we've touched on some of the challenges today already. Data availability is a challenge. One thing that hasn't come up so far today is that a lot of the telco infrastructure is passive. It's not IP connected. You can't measure the energy consumption. You can't, there's no system logs you can get access to. So actually, it's very difficult to have a holistic view of your network and how you can actually reduce energy consumption. There might be other reasons like privacy that we've touched on as well. One option is to synthesize data, and that's something that some are looking into. The other challenges that you have around industrializing the actual models themselves, so interoperability, it's all very well to have lots of different people bringing their AI capabilities into the network, but how do you run interoperability testing? How do you make sure that everything works in harmony? Explainable AI has come up today. It's an interesting kind of topic, given that telco is really responsible for how their networks are operating. And I just wonder, if when you think about things like net neutrality, who's to blame? Is it the operator or the AI for if they're being slightly biased in terms of who they're giving preferential treatment to? And adversarial AI, we haven't really talked about. Although I think it came up in the first panel around security, there's a big danger that when we start to automate the networks, they could be vulnerable to adversarial attacks, where essentially you could game the system so that you always get the best connection within a particular cell as an end user. Skill sets, I think was touched on in the previous section. Interestingly, there's a large majority of the operators that are trying to develop AI in-house. But I think we all kind of have recognized today that it's really going to require a collaboration between both the deep knowledge within the telco sector and the AI sector that really understand the technology and how to bring the two together to really get the best bang for the buck. So just in terms of takeaways, the global economy is fueled by knowledge and information. The digital sector, grows that 6 times faster than other parts of the economy. AI will be an accelerant. That's plain to see. But really it's going to drive demand for a much more holistic fabric of connectivity and compute. So we need to move beyond this kind of notion of it just being about telcos. It's about ICT. It's about bringing everything together. And a lot of those telco capabilities, the future networks, will actually be facilitated by AI. In Europe, UK really punches above its weight when it comes to investment in AI. So we're putting in the money. The question is just whether we can actually then bring that through in terms of developing a smart national infrastructure and really reaping the benefits of a connected society. So that's the challenge. Thank you very much.
I think that was probably a very, very appropriate ending of the day. But I want to invite Dimitra Simonidou to put some closing remarks and for the main takeaways for the day, because I have done enough talking. So thank you very much. Dimitra, it's over to you.
Thank you, Dritan. So Dritan asked me to close because he has done enough talking, and I would agree with this. If we would like to close this. Right, I don't know if you have enjoyed the day as much as I have, but I think it has been a fantastic day. And I always like the venue. The problem with this thing is it's not for short people. So I always like the venue. And today has been extremely well organized. So many thanks to Cambridge Wireless, UKTIN team. Just to mention some names: Lucy, Mary, Mario, and Fiona. I wouldn't go with the surnames, they're long, and I may actually, having a long surname myself, I know how it feels if it is mispronounced. So thank you very much to all the organizing team. We had fantastic speakers and panelists. I think we all debated a lot and learned a lot, and some of us going away with a little gift as well. Not me, but it has been a good day all around. And of course, I would like to thank all the participants. It has been a very interactive day with time provided. Now, Dritan also asked me to give some takeaways, and that is a difficult part. Let us remind you that we are here because UKTIN is about to publish a report, a white paper. I'm not sure if we still call them white papers, a white paper on AI for telecoms, which UE has been leading. And actually, if you like, the central piece of this day was UE's keynote, which set the day, the context of the day. So that's all right. That is what we have. Interchangeable. That's what we have actually to remember for today. But some key outcomes, and the report is going to come out in about 3 weeks' time, become public. You're all going to be able to access it and more, and I hope we are going to enjoy it even more than UE's keynote today. We are going to learn a lot that is going to be a blueprint for AI for telecoms for the UK. So that is going to be a great asset moving forward. Now, AI, is it new for networks? I don't think so. I mean, we are using AI for networks for a very long time. We named it in a different way. But most of the work that we have been doing is really optimizing locally. Do optimization in the radio, for instance. We talk a lot about challenges of optimizing radios, especially when they become more complex. We had a lot of fun playing with Open RAN. Yes, and especially the RIC. RIC is actually a radio intelligent controller. So we had a lot of fun doing XApps, applying AI, doing local optimization of the access network, of the radio access network. Now we are doing more than the radio access network because we start working with multi-technology access. So we go and co-optimize the Wi-Fi, Li-Fi, terahertz as we are moving in 6G and so on. So it's not a new thing. We also, leveraging monitoring network-wide for quite a lot of time. And we have been doing predictions, and we have been doing pre-planning, and we have been doing online optimization, I don't know for how many years. So what makes the change now? I think that the challenge that we have been discussing today is not localized AI, it's system-wide solutions. Because we realize that systems are becoming very complex, very heterogeneous. Actually, managing systems end-to-end they're becoming impossible with classical traditional ways. So we need a different way to actually control, manage, predict networks end-to-end. And when we say networks end-to-end, I go to David's last talk, is beyond connectivity infrastructure because the computational space is as important as the connectivity service. So that is where the challenge is. And we discussed today at several points how we can actually co-optimize horizontally and vertically. So all the way from the application down to the infrastructure. Because when actually I optimize locally my RAN, does this mean that if we do separate the optimization and the RAN, or the management layer, or the application layer, is the global optimization still valid? So local optimization does not mean global optimization. And that's where actually new tools for AI are coming. And traditionally, when we are talking AI for networks, we are not talking about large language models and generative AI, not until now. We have other things like federated learning, transfer learning. We also have been looking at explainability and how actually we can incorporate explainability in our global optimization problems. Again, that's not a new thing. But actually, that system thinking into AI is a new thing, because that's exactly where we are making breakthroughs. And I believe that's where the UK has an opportunity to lead, because of the thinking that we are doing early on in these global problems for delivering network solutions for the future. Now, skills, we talked a lot about skills. Do we have skills for AI in telecoms? We definitely have skills on AI. And as Julie said, they are developing in different places. In maths, in computer science department, in business schools, and so on. So the big challenge for us going forward, because AI is an attractive area, kids want to know AI, they want to learn AI, they want to deploy AI. But the thing is that can we convert this interest and these skills into AI for telecoms? That is a challenge, and I think we have a lot of thinking on how we can make this happen. But I do see, and I believe that these skills are there. The UK government has actually spent millions and millions on AI skills at schools, at the universities, in CDTs. I don't know how many hundreds of millions on doctoral training centers the last 5 years. Enormous amount. How we can take these graduates of our universities, these actually experts coming out of their PhDs, and force them, we don't want to force them, direct them to do telecoms. So those are my key takeaways. Really, I'm sorry if I missed some. I tried to summarize. And I would like to close here again. Massive thanks to everybody. Please don't forget that there are 5 exhibits downstairs and more refreshments. So stay around so we can chat and reflect for the day. Thank you very much.